If you're unaware or haven't been involved in application development a lot lately, you might understand that there's a lot of hype around microservices these days. And a lot of our customers, a lot of our colleagues, a lot of our clients are adopting this microservices architecture, and they're having mixed results. Some of them are doing it very, very well. Some of them are having growing pains. And what a lot of it comes down to is good collaboration capabilities, good communication capabilities. And to improve those communication capabilities and collaboration capabilities, we need a clear way for multiple teams that are working across various different services to work in parallel without having to worry about, hey, team A implemented XYZ, but team B implemented AYZ, and now they don't quite work together. This goes back to an old concept that's been around for a while of an API contract. If you come from C++ development world, you're familiar with header files that describe how you interact with an API. If you're coming from the Java world, you're familiar with interfaces that describe how you interact with a certain library. Those are contracts. But how do we take that concept and move it to the web API world? Well, there's a number of ways we can do that. The thing that we're trying to achieve by moving to microservices is to get things like continuous integration, to get things like pipelines, to get things like continuous testing, microservices, and continuous delivery. And without this clear collaboration, this clear integration point, what we often see customers, clients, colleagues end up with is chaos, integration issues, misunderstandings, waiting, and blockers. Hopefully you've heard this term before, but I hear this a lot from my clients and customers that I've worked with. An integration party, which sounds fun on the face of it, but I can tell you for sure that it's not fun at all, because it's trying to figure out what one team did that isn't working with another team's product and why they won't integrate. Those integration parties can be huge blockers when you're trying to get a product delivered. I love this quote. Jez Humble is part of DORA, the DevOps research group that involves Dr. Nicole Forsgren, Gene Kim. They now work under the auspices of Google's Alphabet parent company. And this is a really big reminder to everybody that's looking to implement microservices. Microservices are distributed systems, and distributed systems are hard. So don't take on microservices unless you absolutely need them. And we need to be educating our customers, because we're finally over that hype curve. I think we're starting to head for the trough of disillusionment around microservices, and understanding that maybe we shouldn't do everything as microservices. Why am I talking to you, and what bona fides do I have to actually give you information? Well, my name's Deven Phillips. I've been a senior consultant with Red Hat for now 3 years. I started out with Open Innovation Labs. Before that, I've been a development team lead at a couple of different companies. I've worked in various startups. And I've been doing microservices, and especially container-based microservices, for about 8 years now. I am heavily focused on DevOps and Agile. I was doing DevOps before there was a term DevOps, and we just called it automated infrastructure and automated development, continuous integration, continuous delivery. And that's where I'm coming from to try and give you an idea. These days, I am now a senior consultant in the Cloud Native Application Development practice under the Solutions and Technologies group, with Nick Hopman leading us up. And our team is helping to develop curriculums to teach the rest of consulting how to do cloud native app dev. So why would you want to adopt ContractFirst? It really comes down to just a couple basic concepts. Regardless of if you use code generation with your ContractFirst API, having a simple format for sharing your contracts is amongst all the users of that service is of significant value. Let's learn how expressive that can be. Traditional workflow of writing a REST-based API or a gRPC API or something is somebody does some project planning. You get business analysts, product owners, and things like that together. They do this huge product increment planning and write up a project plan. They deliver that project plan to the developers in plain English in documentation, and those developers start reading it and try to understand it. The developers then implement that product plan. Let's say you have 3 teams working on back-end services, 1 team working on front end. They're all reading that product plan and implementing it as they understand it. But what generally happens is at the end, they realize they've interpreted that project plan slightly differently or vastly differently. And they have lots and lots of integration issues and spend lots of time resolving those integration issues at the end of the project. Using a ContractFirst play, we can go to using an API specification, something like OpenAPI or Swagger. And we write that API specification, and because it is a standardized format, there is almost no ambiguity. So when we hand that API specification off by publishing it using a tool like OpenAPIGenerator, which is something that we help promote, those developers can generate a great deal of the code, and then all they have to do is implement their business logic. So in going and by scratch creating a Spring Boot microservice or a EAP application that presents a REST API, they generate most of that code from the specification, fill in the specific business logic, and it just works. On the converse side, the front-end people that are doing integration with that backend, we can actually generate a client SDK in JavaScript, in Java, in Scala, in whatever language that just presents them with a library that they import, and they just call methods against that library. So instead of having to know, I need to connect to this web server and use this path with these parameters, they just say API client dot get to-do list. And because it's type safe, or can be type safe, they get IntelliSense or autocomplete help to say, you need to provide these parameters in order to call that method. There's another option that we can approach. REST isn't always the best option for implementing an API, so we can use a tool like gRPC. And this was something that was started out at Google. It's now a pretty well adopted standard. And you write the gRPC specification using a format called protocol buffers. And then you can use a tool like GitHub or GitLab or whatever to publish that API specification. And you can generate your code, your basic structure of your application or your client SDKs using Proto-C. Sorry, my dog is going crazy in the background. And then we just implemented our specific business logic. Today we're going to focus on OpenAPI, and I'm going to walk you through what an OpenAPI specification looks like real quick. What can you define in an OpenAPI specification? Well, you can define data types or object types, class types. You can define REST API endpoints. You can define HTTP verbs like get, post, put, delete. You can define the parameters, whether they're path parameters or get parameters. You can define information about how you're going to implement security. So you can specify that, hey, my REST API is going to use HTTP basic auth, or it's going to use OpenID Connect, or it's going to use OAuth, or it's going to use API token. And you can also extend OpenAPI, and I'll talk to you a little more in detail about that here in a little bit. Here's what the header of an OpenAPI specification looks like. It allows us to set up information like the version of OpenAPI we're conforming to, the title and description of our API, the servers that we expect to serve that API from, the license that we're publishing our API under. This is what type definitions look like inside of our API. We define a component or a schema for a type definition. We're saying that this is an object. It has some required fields before we can actually use it. And then we can specify details about the fields that are part of that type. So in this case, The ID is a string and it's formatted as a UUID. We can also specify that we want to be able to generate this as XML as well as JSON. And type definitions also support enumerated data types. Then we have our HTTP endpoints, or our paths. So you can see here that we have /store/order, that it's a post HTTP verb. And this operation ID is actually really useful if you decide to use the code generation capabilities. When you use a code generator, this operation ID becomes the name of the method that either the client or the server decides to implement. We can specify the type of content that our request body will handle. We can specify the types of responses that we're going to send back from this REST endpoint. And you'll see here that we support both XML and JSON, and we're referring to the type definition from the previous slide. Then REST APIs can also accept parameters. Again, we have our GET, and we see that with this GET operation supports some query parameters. So those are the ones that go in the URL with the question mark, and we've got a start date, we've got an end date. We indicate that those parameters may or may not have to be present, and we can specify what type and format those parameters are in. Alternatively, we can have path parameters. So like our order ID over here, and we specify that this parameter is in the path, that it's always required, and what the format of that parameter would be. Talked a little bit about how you can specify information around how you're implementing security in your API. Here's examples of basic auth, bearer auth, API keys, OpenID Connect, OAuth 2, so on and so forth. And then finally, we'll talk a little bit about how you can extend OpenAPI. Some toolkits, frameworks, platforms have gone even further with integrating OpenAPI in that the language, the toolkit, or the framework supports it directly. So instead of generating code, your API specification can be consumed by the toolkit or the framework. Here's an example using Vertex. Vertex has a capability called Web API Contract, and we can add this extension to the OpenAPI specification. Anything that starts with X dash in OpenAPI is an extension. And this lets Vertex know what event bus address to attach its methods, its handlers to for this API. And with that, we're going to move on to some of the tooling that can help you leverage OpenAPI to deliver business value faster. OpenAPI has lots and lots of tooling, from editors to server implementations, client generators, testing tools, mocking tools, and validators. All of the editors that I'm going to talk about in this deck are pretty much all open source, freely available. There's Apicurio, which is a project and product that is managed and provided by Red Hat. There's Swagger Editor from swagger.io. Visual Studio Code has plugins. IntelliJ has plugins. Eclipse has plugins. These all work really, really well. For server implementations, this is where we take our API spec and we generate a server application from it. We can use tools like OpenAPIGenerator or Vertex Web API Contract, Web API Service. MicroTS is a TypeScript Node.js Express implementation that instead of you generating code, it actually consumes that OpenAPI spec, and you just attach functions to the operation IDs, which is even better in my opinion. Same way with Smart Recruiter's OpenAPI First. I'm sorry, MicroTS, I take that back. That may not be the JavaScript one. The Smart Recruiters one is JavaScript and Node Express. For client implementations, again, OpenAPIGenerator can generate clients as well. We can use Web API Contract in the Vertex world. Vertex, because of its polyglot capability, can actually generate clients in whatever languages are supported, like JavaScript, Scala, Kotlin, whatever. There's a tool called APImatic. That one's a software as a service. You upload your OpenAPI spec and it can spit out a client implementation for that API. OpenAPI Client Axios. This one consumes your API specification and then gives you an Axios promise-enabled asynchronous REST client. And then we can use testing tools like Dread. So if you've ever started writing an API and you wanted to do testing of that API to ensure that you're implementing what you think you're implementing, this can actually save you a whole lot of time. Instead of writing a bunch of unit or integration tests or Selenium tests, whatnot, these testing tools can just take your OpenAPI specification, look at the examples and parameters that you've defined, and they can validate your specification right from your spec without you writing any code. And so some of these tools are Java-based, some of them are CLI-based, some of them are JavaScript-based. Dread is a CLI-based tool. It's a little flexible, but not super flexible. Chai is for JavaScript world. You can integrate with Mocha and Chai and validate your OpenAPI request responses. Hikaku is written in Kotlin, but also compatible with Java. Assertable is a software as a service where you can upload your spec to their SaaS offering and point it at your service and have it validate everything for you. That way, when you go to implement that API, you have a clearly defined finish line to know when you're dev done with that API. And with that, I've rushed through these slides pretty quickly, but we're going to do a bit of a demo. And I'm going to switch over to VS Code. You can obviously do this in just about any IDE. Oh, before I go to VS Code, let's exit out of my slide deck here. And let's open up a browser window and let's talk about Apicurio. Apicure.io. Why am I typing that wrong? So Apicurio, as I said, Andrew McKenzie and his team with the integration, they built and maintained this integrator. Try live. I'm going to zoom in a bit because I'm on a 4K screen. I'm going to log in with my GitHub account. And at this point, we can now create a new API. So I'm going to create a new API, and we're going to call this to-do demo consulting. I'm going to choose that I'm implementing this in OpenAPI 3.02 version. I'm going to start with a blank API, and we're going to create this API. Here's where I find Apicurio is super useful for me. So I'm going to start with adding a data type. And we're going to call this data type a to-do. We can give it a description. But what's really important is we can put an example JSON block in here. Have that have a title. It can have a description, maybe. Let's see, what else would a to-do list manager need? Maybe created date. What is today? The 4th, April 3rd, right? Yep, April 3rd. T, and it is 11:52 and 0 seconds and 0 microseconds. We're just going to put Z because I prefer to work in UTC, even though I know that's not the current time. What else would we need? Oh, is it completed? We're going to default to it not being complete by default. Example JSON body here. And we can go down inside of Apicurio and choose to have it generate most of our REST API for us by choosing this REST resource. So when I click save, not only did it create the to-do data type, and describe it here, it also created most of the CRUD operations definition in our OpenAPI specification. So if we look at this top level and go to the source, we'll see that we have a almost complete OpenAPI specification. One thing I will tell you as a caveat, some code generators look at this title of your schema, and when they generate an entity type or a POJO or whatever from this, they try to name the POJO using that title. In Java, that doesn't work out so well many times because of the naming, so I usually just rename it to something simple. So you'll see that it detected that our created is a string of format date time, the description is a string, the title is a string, complete, it detected that it's a Boolean. It set up our parameters for our REST endpoints. It set up our request bodies for our endpoints. All of this was done for us automatically. So we can then take this OpenAPI specification and start generating some code from it. So I have that same OpenAPI specification here in my IDE, and I'm going to use some tooling to generate a Quarkus REST Easy server from that. This link is in the meeting invite to the demo script, and it will take you to this README file that will walk you through the steps that I'm going through now, including using Apicurio. And we just downloaded our API specification. We're ready to do getting some feedback. One of the things that the current DevOps trend has been teaching us is that we want to get fast feedback from our customers so that we don't spend a bunch of time implementing code that doesn't really solve the intended problem. We can use a tool called API Sprout to stand up a fake instance of our REST API, no code required. So this command right here allows me to run a Docker container with API Sprout that stands up a REST implementation using our example data from the API specification. And we could publish that to, say, a customer or a stakeholder or another team that wants to integrate with our service. And we could get feedback and say, hey, is this going to do what you need it to do? And they might say yes, or they might say no. In our scenario, what I'm going to say is that we got some feedback and the customer is telling us, hey, the to-dos need a due date. So unless you have a due date in there, it's not going to meet our needs. So we would switch back over to Apicurio. Oh, if I can get to the right browser window. And we would go into our data type for to-do. We would add a new field, and we'll call this due date. And the property is not required. And we would click save. So now we have a due date in our spec. We can tell it that the property is not required. It's of type string, but it's a date time. So now we've saved this. One other thing I want to point out about Apicurio real quick. Right now, if you use Apicurio, you can collaborate. So if you go up one level, you can add collaborators to your Apicurio instance. And as long as you're using the graphical interface, multiple people can be in here editing things at the same time. In the future, Andrew McKenzie and his team are planning to add multiple editors in the source code view as well. Don't have a timeline for that yet, but keep a lookout for it. So now we've got this updated specification, and if we look at our YAML here, you'll see that I've already added it in my implementation here, due date. So I'm going to take that, and our stakeholder told us, yes, that's exactly what I want. You're doing the right thing. We're then going to take that API specification, and we're going to clone this project, which I've already done. This project has the skeleton of a new Quarkus REST easy application. There's not actually any code implemented. It's just the Maven POM file and some configuration. And I've also got a set of database migration scripts for FlyWayDB. But you could write that after the fact as well. And then we're going to install OpenAPIGenerator. OpenAPIGenerator is actually a Java executable file, but they published it to NPM to make it easier for people to install. I guess that's easier, maybe. And once we've installed it, we can generate a JAX-RS server. Now, I mentioned in the demo diagram or the demo document, the generators from OpenAPIGenerator have varying degrees of completeness or support. The JAX-RS generator is actually one of the best ones, I think, personally. It does a lot of really good stuff, and it implements things so that if at a later date we update our OpenAPI spec and we regenerate our code, it will not overwrite our implementation code because it puts the generated code in a separate directory, and it allows you to implement based on an interface in Java, so that if you regenerate the code, the interface gets regenerated, but your implementation code doesn't. And then you'll just get little red squigglies in your IDE telling you what you need to implement to comply with the updated specification. The OpenAPIGenerator, though, does not have direct support for Quarkus. But that's where we have another superpower here, is that inside of OpenAPIGenerator, there are mustache templates for all of the various different implementations. We can copy out the JAX-RS templates, and we can modify them. We can customize them in any way we want, and then we can tell OpenAPIGenerator to use our customized templates. And that's what this second command is doing a little more in depth. We've put the configuration we want to use into a separate YAML file. We're telling it to use our customized templates for Quarkus, and we're also ignoring some files we don't need to output. In a typical JAX-RS REST Easy app, we would need to bootstrap the application. Those aren't needed in Quarkus. We would also need Jackson serializer information, stuff like that. That's already built into Quarkus. We don't need to worry about it. And then we output it to a folder. So I'm going to run this command and show you what we get out of the code generator. And if you look up here, we have a to-do server. And in that source directory, we have this source gen directory. This is all of our generated code. So it generated our POJO models. It generated the JAX-RS API implementation. So all of our typical JAX-RS annotations, our Swagger annotations, they're all here. And it has wired it to a service. It also generates the interface for that service. So in to-dos API, it injects an instance of that service interface. So all we have to do as developers at this point of the backend is implement the to-do API service implementation. So in Quarkus, we would make that class request scope so that it's wired into CDI. And because our to-do entity is based on Quarkus's Panache entity, we already have sort of a DAO built in. And so we can just say for our create to-do method, we can just say, so we need to implement the API. So what we do is we say to-do dot persist and flush. All you need to do in Quarkus. And then is our entity response, we just put to do. And because Quarkus has built-in JSON-B support, it's going to automatically serialize this when we send that response and send it as JSON. or XML, depending. Same way with our delete. So our delete is going to do something along these lines. We're going to have to do target equals to do dot find by ID to do ID. And we're going to need to wrap that in a try catch, because what if that ID doesn't exist? Exception E throw new not found exception. That not found exception is actually created by our OpenAPI generator, and we can just say e.get localized message. That will automatically return a proper 404 message for us. And then instead of returning a response OK, if we make it past that find by ID, we're then going to say target.delete. Code not cooperating. And we're going to say response.no content. And so this will return a proper 204 response to a delete, saying that, yes, we successfully deleted that object. One last thing we need to do to any of the methods that are going to modify data in our database, we need to specify that those methods are transactional. Otherwise, they will not work properly. And so we would go through and we would continue implementing these methods. The most difficult one to implement is update to do, because we actually have to pull down the existing instance from the database, take our updated instance that we get as our request body, and we need to manually assign each field. If you've ever implemented a REST API, this is probably the fastest, simplest workflow you've ever seen for implementing a REST API. And that's it. That's all we would have to do to implement this Quarkus API. I'm actually going to go switch over to one where I've already implemented this for the sake of time. And you'll see in my to-do server, I've got those same generated pieces of code. And if I go into Java to do API service implementation, here are my actual implementations. This is what I was telling you about with the update to do. You have to manually get and set, get and set, get and set, and then persistent flush. There's that transactional annotation I was telling you about. Any method that modifies the database needs to be transactional. And with that, we can just say Maven, clean, compile, Quarkus, dev. Oh, wait, we need a database. So in my demo, I actually have a Docker Compose file that will start up a local instance of Postgres. So we're going to start that up. Give it a few seconds to finalize, and we'll say Maven, clean, file, Quarkus, dev. Now, does this only work with Quarkus? No, absolutely not. If we switch back over to this browser, this is the web page for OpenAPIGenerator. OpenAPIGenerator actually has client generators for a number of different languages and frameworks. It has server generators for a number of different languages and frameworks, documentation generators, database schema generators, and configuration generators for things like Protobuf and GraphQL and Apache Web Server. Another website I want to call out real quick is this one, which is openapi.tools website. And it's sort of like an awesome repository of everything related to OpenAPI. So they have tools for converters, data validators, description validators, documentation, DSLs, editors, learning, mock servers, parsers, security, testing. We talked earlier about API Sprout. It's a mock server. We also talked earlier a little bit about testing. Here are some testing tools that you can use. And all of these basically make it one shot, no code required to test your OpenAPI application. So our Quarkus app is up and running. I'm going to open a new terminal. I'm going to say Perl http://localhost port 8086 API v1 to-dos. And there we go. I got an empty array. That's what I would expect. At this point, I actually have a working REST API, and I only implemented 17 lines of code. Everything else was generated for me. Now, I will admit, this isn't everything, and sometimes this generated code is not as flexible as we would want for a really robust implementation. That's where I hope I can encourage all of you to start getting involved with tools like OpenAPIGenerator, tools like Proto-C, gRPC, and we can start improving it and making it more flexible, more capable. The other things that I wasn't able to automatically generate are like the Quarkus application properties for how to connect to the database, and the database migration scripts that I used to create my database tables. Those are not automatically generated. I had to manually create those. The next step would be that we would do a lot of this code generation in a pipeline. So you'll see that I actually have Jenkins files for running these code generation tools and build and configuration tools in a Jenkins pipeline on OpenShift. So we've got our backend running. The next thing we need is a front end. And in our case, the front end is something I've already written. It's a Vue.js application using a framework called Quasar. But what it's missing right now is UI. And if we go under source, pages, index, wrong page. I want layouts, my layout. That's what we want. So what it's missing right now, sorry, it's actually already implemented. What we need is a way for this Vue.js application to talk to that REST API. And what I'm going to do here is I have generated a TypeScript JavaScript client that uses Axios. And it creates the API and the types, just like it did for the Java code. So if we look at API TS and we look and see that it has defined the to-do type and all the various fields of that type, and then it's also created all of the supporting code so that when I instantiate this client, I just say API client.getToDo. And I know that I need to provide a to-do ID, and I can provide request options like REST API request options that Axios would typically take. This options is the standard options for an Axios client. And it returns a promise that will be resolved once that request completes. So very standard front-end JavaScript development flow. And if we look, what I've done in my UI is I've installed that generated client as a library in part of my application. In Quasar, if there's something you want to configure at the start of the application, you create a boot file. And that boot file would look something like this. I'm going to call it API SDK.JavaScript. And this boot file will say export default, or actually, there's a better way to do this. Quasar has a simple tool for this. So if I go back to my terminal, cd to do UI, and we go Quasar new boot API SDK. Quasar generated a new boot file that I can then implement, and I want to pass in the view instance. And in that view instance, I'm going to say view.sdk equals import my SDK, import default API from to-do client SDK. We're going to say view.sdk equals new default API. These are our default Axios options. I'm going to leave that null, and then we're going to point it at our API. Oh, it's complaining because I use double quotes instead of single quotes. My ESLint settings are choking me a bit. And I don't need an async. I'm not going to put an async. Now what's it complaining about? Missing semicolon. Where's a missing semicolon? I think VS Code's just, oh, it wants a semicolon there, doesn't it? All right. So now anywhere in my Vue.js application, because I've modified the prototype for the Vue class, any of my Vue items, here's another place where you could put that client SDK, but any of my Vue items can access that API client. And I would access it via this.API SDK or this.API. In my implementation, what I do is when I want to start this page, I get all the to-dos from the REST API just by calling client.getTodos. When I get the result, a successful result, I just put those to-dos into my data block for the Vue renderer, or I handle the error. And so I could actually start this up by saying Quasar run unhandled promise rejection. Well, isn't that fun? Cannot read property char at undefined. npm install. I might have something missing from my npm install. How are we doing on time here? We've got another 15 minutes. Okay. Quasar dev. And we'll see Quasar start up. Do I have, yep. So you'll see that my default API endpoint is already pointed at the Quarkus application I have. And here is our to-do app. I'm going to zoom this in a little bit. So if I want to add a to-do, I could call this give session explaining ContractFirst API to my Red Hat fan about the benefit of ContractFirst development. And I can set a due date for that. Maybe I want to set it for today in about 15 minutes. So actually today is 12:30 p.m. And I'm going to add that to-do. So now our to-do is done. It's actually in the database, so if I reload this single page application, it's still going to pull it from the back end. I can mark it as complete, and it goes grayed out. I can unmark it. I can delete it. With that, demo done. I was planning on going into a little bit more about testing, but I didn't really feel like I have time today. I want to open it up to questions. And Jarrett, if you could start feeding me some questions, that would be great.
So the first question is, can we see your dog? From Kevin Granger.
Can we? You probably could. He's a fat little beagle Jack Russell mix, but he's downstairs.
And if anyone has questions, please enter it in the chat, and we'll make sure that we get them answered. Because at this time, we have no questions. You were so good that no one has any questions.
That's
frightening.
Never a good sign, in my opinion. So let me state real quick. Probably many of you, at least the more senior developers among you, have had interactions with code generation tools in the past. And if you're anything like me, those interactions have not been good interactions, or not happy interactions. I will say that OpenAPIGenerator is probably one of the best code generation tools I've ever used. The client-side stuff I've never had to tweak, period. It just works. The back-end stuff takes a little more effort depending on which implementation, which generator you're using. But because most of them are structured so that they generate code in a place where you won't have to overwrite it every time, better than most. All right.
So why does the existing JAX-RS generator not work with Quarkus?
So it does, but you would actually have to modify some of the generated code. The Java generators, all of the Java generators are based on a root class. And when it creates POJOs, those POJOs do not have things like Hibernate annotations, JPA annotations. They are not set up to extend things like Panache entity. So you would actually have to go in and modify those POJOs by hand. And if you regenerated the code, well, that might overwrite it. You can tell OpenAPIGenerator not to overwrite the files, though. Oh, sorry.
Yes, he is in front of a green screen. Earthquake.
Yes, I am in front of a green screen.
Do you have an example of implementing custom client-side validation along with generated clients and types?
Do I have an example of custom client-side validation? So the OpenAPIGenerator, that to-do client SDK that I created, actually has validation built in. If you try to create an instance of the OpenAPI client that I generated and you feed it invalid values, the validation that's built into that client SDK will throw an exception in your JavaScript code and let you know what you did wrong.
What tools do you use for API versioning?
API versioning. I usually, in my OpenAPI specification, put the version inside of the OpenAPI spec. I'm not sure if I'm answering that question appropriately or not.
Michael, do you have, that's from Michael Acosta Medio. If you would ask a follow-up question if that did not answer your question.
So it looks like we got a question about Apicurio versus 3Scale and how they should complement each other. I just went through this with a project I was on. So 3Scale has some support for just importing an OpenAPI specification to configure it to work with your API. I did not get that far along in the project. Unfortunately, the customer suspended the project before we finished that work because of coronavirus. So I do know that if you look at the 3-scale documentation, I am by no means a 3-scale expert. They do have support for just configuring an API straight from an OpenAPI specification. How good that support is, I couldn't tell you.
So some customers are big and have old methods of contract negotiation between teams. Do you recommend larger corporations migrate to this solution, or is this best for greenfield projects?
So the approach that I showed you today is best for greenfield projects. That said, I'm working on documenting and preparing a presentation for legacy applications, brownfield development. If your customers are already using things like Swagger to document their APIs for publishing with Swagger docs, you can actually relatively easily transition away from code first, which is the traditional manner, to contract first, because you can take that generated Swagger JSON and you can publish that in, say, Apicure or whatever, and you can set it up using the OpenAPIGenerator ignore files so that you're only generating new code and the legacy code remains the same. OpenAPI specification requires that if you have a specification and you have code, and it has to merge them. So it would show both and keep them both up to date, and you can put them alongside one another, no problem.
Have you ever
used
custom? If you have a follow-up question on it, please post it. Have you ever used customer-driven contacts, and if so, could you use this as a way to implement CDCs? And I'm assuming that's not the Center for Disease Control. It's consumer-driven contracts.
So, Bob, I don't know. I'm not sure. I'm not familiar with that term, consumer-driven contracts. But you're on my team, so feel free to reach out, ask me, and we'll go through it. I know I still want to talk to you about T cases for automated testing as well. Matthew Bach, can you point us to more resources available from your team aimed at upskilling delivery consultants? Absolutely. I highly recommend you go and look at our GitLab. We are in the consulting GitLab, so if you go to gitlab.consulting.redhat.com and go to the app dev practice, we have a documentation repo with a wiki where we've been publishing things that we intend to share out with the broader Red Hat consulting organization.
Is that available to partners as well?
I do not believe it is available to partners. It's available to anyone with a Red Hat Google Apps account. As far as partners go, yeah, I don't have an answer for that, but hopefully Marshall Powell, my people manager, and I can maybe discuss with getting some of that curriculum out to GPTE. That might not be a bad idea.
Are these tools limited to Java development?
Absolutely not. So if we go back to that generator list for OpenAPIGenerator, you'll notice that the languages supported are all over the place. I mean, we've got Ada, for God's sake. C, C#, C++, Erlang, Elixir, Groovy, Java, JMeter, Kotlin, Lua, Perl, PHP, Python, Ruby, Rust, Scala, lots of different TypeScript implementations. This TypeScript Axios is the generator that I used for my client SDK. It works really, really well. I love this thing. And then the server generators again.
What was the specific client-side generator that you used?
TypeScript Axios. This one right here. This worked really, really well for me, and it gives you type hinting in your IDE, so you get like autocomplete IntelliSense kind of support when you're calling the API. It's really, really nice. There's a lot of customization options. So if you go to the OpenAPI generator homepage, which is openapi-generator.tech, there's this section on customization, and they explain to you what kind of configuration options you can feed into the OpenAPI generator. Oh, that reminds me, I forgot one more thing. If you're using Apicurio and you go to the top level of your API, Apicurio can generate projects for you as well. It's less involved and it's not as complete as what you get from OpenAPI Generator, but I've been talking to Eric Witzeman, and we're looking to improve this going forward. But right now you can generate simple JAX-RS, Quarkus, or Thorntail directly from Apicurio.
Just for the record, they can't see your screen, so if you're pointing to the screen, they can't see.
I apologize, you're right. I forgot to share my screen on that. Let me do that real quick. Start sharing, come on. Come on, Blue Jeans, catch up with me.
And we have about 2 minutes left.
2 minutes left. Can you guys see my screen now?
Coming. There, I got it.
Okay, so right here on this top level of your API, you can go to Generate Project, and it'll ask you if you want to bootstrap a new project, and you can generate simple Quarkus or Thorntail JAX-RS projects. As you can see, Vertex, Spring Boot, and Node.js are on the agenda to be addressed in the near future, or in the future. I don't know about near future. I can't speak for that engineering team, but I know I've been discussing it with them. And I told you about OpenAPI generator customization. I'm trying to load that page right now. It's taking its sweet time. There we go. Customization, you can feed in lots and lots of command line arguments to your generator, or you can use the Maven plugin with your generator. With this customization, you can say, oh, hey, I only want to generate the models, or I only want to generate the APIs, or I only want to generate supporting files. You can customize the ignore. So OpenAPI Generator can ignore outputting certain files or wildcards and things like that. There's lots and lots of knobs and sliders and dials and buttons that you can tweak inside of OpenAPI Generator. And back to the OpenAPI tools site, that is not the only generator available. So if you look at server implementations, there are lots and lots of different server implementations aside from OpenAPI Generator. Same way with client implementations, SDK implementations, so on and so forth. And I think that pretty much puts us right at time.
If you have any other questions, please send us an email. You can email me directly at japotts, Japotts at redhat.com. And of course, you can email Deven as well. Deven, what's your email?
So my email is deven.phillips at redhat.com, or josphil, Josphill, at redhat.com. Or
because those match so well.
There were too many Josephs on my ship in the Navy. We all ended up with nicknames.
All right, with that, we'll conclude. Thank you all for attending.
Thank you all for your attention and your questions.